we have it's the same thing.
Just to show them what. Okay.
Hi, today in this lab we are going to find out the stoichiometry of the reaction, the yield of a reaction. So when we in a reaction, one of the reactant will react with a given amount of another reactant. So we find out the amount of reactants reacted and the amount of products formed. From that we find out a stoichiometry of reaction, and from that we can develop the chemical reaction equation for that process. So for this purpose, we have taken 6 test tubes labeled A, B, C, D, E, F. And in this test tubes, I am going to add boiling chips first.
Show me. What is it?
This is the anti-bumping granules.
Okay.
It allows to boil without the boiling in it. So I am adding to this will never reacts with the this will never include in the reaction. It will stay like that. Okay. So now next we want to measure the weight of these all test tubes, these empty test tubes. So for that I will show you the weighing machine, and we will measure each test tube's weight and we will note it down.
Okay.
So this is the weighing machine. So I am going to measure the test tube A with this boiling chips. Okay, so to hold I have kept a beaker as well. So now it's 0. So I am keeping this on the top, and I am noted down the weight of test tube with this beaker. That is 41.66 gram. So test tube A 41.66 gram. Now I can measure test tube B. That is 41.52 gram. 41.52 gram. Same like test tube C. 41.71 gram. So test tube. Next we can measure test tube D. That is 41.67 gram. 41.67 gram. test tube. Next is weight of test tube E with the boiling chips. It is 41.65 gram. Next is weight of test tube F, that is 41.70 gram. Okay. And next we can go back to our lab. So for the experiment, what we are going to do is we are going to fill this A, B, C, these three big test tubes with sodium bicarbonate, sodium hydrogen carbonate, that we will fill until this curved portion, and it will cover this curved portion. We will fill up to that part the sodium bicarbonate. Same like for D, E, F, these three labeled test tubes, we add sodium carbonate. And then we weigh the weights of this component. Then we add the 6 molar hydrochloric acid slowly and find out the reaction, and we dry it out and find out the product weight. That's what we are going to do. So now I am going to add for these three test tubes the sodium bicarbonate. So this is anhydrous, sorry, this is the sodium bicarbonate.
Show me the writing. Okay,
so sodium bicarbonate. So I am going to add this, taking a granule. So for A first, until this curve, until filling this curve portion. Okay. Now the curve B. Now for the C. This A, B, C are filled with sodium bicarbonate. See? Okay. So the next three test tubes, that is D, E, F, we are going to fill with sodium carbonate. So this is the sodium carbonate. So I'm going to fill this sodium carbonate and the E. Okay. So I fill this three other test tubes with sodium carbonate. Now we are going to measure the weight of this test tube with sodium bicarbonate and sodium carbonate. So but from the difference we can find out the weight of sodium carbonate or sodium bicarbonate. Okay, so I'm going to note down the weight of this test tube with so now it's mass of weight of tube A with sodium bicarbonate. So we are going to measure its weight. It is 42.31 gram. So I am noting it down, 42.31 gram. So next I am going to measure weight of B with sodium bicarbonate. That is 42.26 gram. 42.26 gram. Next, I am going to measure weight of tube C with sodium bicarbonate. That is 42.44 gram. Now, next we are going to measure mass of test tube D with sodium carbonate in it. that is 42.4 gram. Next we will be measuring mass of weight of the test tube E with sodium carbonate in it. That is 42.47 gram. Next, weight of test tube F with sodium carbonate in it. That is 42.35 gram. Okay, next we are going to add acid to this component. So next we will be adding 6 molar hydrochloric acid to this all components, that is sodium bicarbonate and sodium carbonate. But while adding, we will add drop wise slowly, and we will let it run down through the walls of the test tube and reacts with the component. And at the same time we need minimum amount of acid for the reaction. That's why we will add drop wise and see how the dissolving capacity of this component, and will allow to dissolve in the minimum amount of hydrochloric acid. So first I am taking test tube A. This is sodium bicarbonate, and this is 6 molar HCl. It's highly corrosive. So I am taking it drop by drop and adding drop. Now the HCl is reacting with the given sodium bicarbonate, and it is dissolving in given HCl solution. So we need minimum HCl for dissolving. That's why I am looking at, if it's dissolved completely, then we don't need to add more HCl. But it has slightly at the bottom, so I am adding a little bit more. Still little bit.
Just without checking, just to show them the reaction.
Yeah. Still there is a slight at the bottom. I'm adding one more drop.
Just 1 second.
Okay.
Okay. Can we see it?
Still, I think there is some.
Do not check, just to see what we have.
So I'm adding a little bit more.
Now, yeah, at the bottom you see, just I'll try focus. Yeah, sure, it's exhibit on this one, at the bottom.
Yeah, at the bottom it's the rest of sodium bicarbonate reacting with HCl, and we can see that reaction.
Okay.
I think we need to add a little bit more, right?
Stop. And how they can see the reaction. Okay.
Okay.
You can see the reaction now. Like this, clear. You see how it is reacted? This the reaction is going on now.
Mixing it up so react fast.
Even without checking, it is going on. Almost finished.
Yeah.
Yeah, almost finished now. Everything is clear. Solution.
The solution is clear now.
It's about to finish.
Test tube A with sodium bicarbonate we dissolve with HCl, and now it's clear solution. Same kind we will add for all test tubes for the B, C, D, E, F with this 6 molar HCl, and we dissolve and make it clear solution. Then we'll show you the end of result.